be there on the double whenever there's a problem.
Welcome to another episode of Math and Silly Hats, where I'm here to rescue you from systems of equations. Today, we're going to be solving another linear system of equations. Here, I'll be doing a medium difficulty problem wherein we do not already have a variable isolated. So much like yesterday's episode, we're going to be trying to find the values of x and y in two different equations. The same value of x and y should make both of these equations true. Now here, we do need to do our first step in isolating a variable, since all of our variables have coefficients. Let's be strategic about this. Because these coefficients are all divisible by 3, it seems that our first equation may be easier to isolate a variable in. Our second equation has smaller coefficients, but notice if we were to divide everything by 2, we'd end up with fractions on both of these terms. And if we divided everything by 3, we'd end up with fractions on both of these terms. So I'm going to choose to isolate a value in my first equation. I'm first going to rewrite this equation. 3y plus 9x equals 9. I would like to isolate y here, because when I divide everything by 3, I'll end up with integers on both of these terms. Whereas if we were to try to isolate x and we divided everything by 9, this would be a fraction. Though that will work, I'd recommend avoiding fractions since these problems are already complicated enough. So to get y by itself, to isolate y, what we're going to do is we're going to move all the other terms to the other side, and then we're going to make sure we don't have a coefficient on y. I see a term 9x here. I would like it to move to the other side, so I need to do the opposite operation. It's being added to 3y. I'm going to use the opposite operation of addition, subtraction, and subtract 9x from both sides to move this term away from the variable I'm trying to isolate. So I haven't touched my 3y. But when I subtract 9x from 9x, that term will vanish. I'll get 0, and adding 0 to 3y gives us 3y. Over here, I'll have 9 minus 9x. Now you may be tempted to say 9 minus 9x is negative x or 0, but these are not like terms. Notice this term has a variable x, whereas this is just a constant, so these cannot combine. Now I need to get rid of the 3 in front of y. Well, coefficients multiply their variables. So to get rid of that 3, I need to do the opposite of multiplication. I'll need to divide each side by 3. Now notice, when I do that, I'll have to divide everything on the right side by 3, not just one term, since what I do to one side of an equation, I must do to the other entire side of the equation. On the left, 3y divided by 3 will give us y. Our goal was, again, to isolate a variable, equals 9 divided by 3 will be 3. Negative 9x divided by 3 is negative 3x. So we have isolated our variable. I've rewritten what we had just found, that y was equal to 3 minus 3x, below our original two equations, and I want to make note that how I got here was from the first equation. Since our second step is to substitute the value of the isolated variable, here y, into the other equation. So I can substitute this into the first equation, since that's how I got it. The other equation would be my second equation here. So let's substitute the value of y into this equation. What I'll do is I'll rewrite my second equation, 2x plus 3y equals negative 5. You'll notice I didn't write y after 3 because I'm going to be substituting its value from our first step into this equation. So because we know that y is equal to 3 minus 3x, instead of my y in the second equation, I'm going to write its value, 3 minus 3x. Now, we need to solve for the remaining variable. If you notice, this looks complex, but it only has one variable, x. So we can now solve for x. I have parentheses. I'll start with those, as that is the first in my order of operations. Outside of my parentheses, there is a 3, a coefficient, meaning it's going to get distributed or multiplied by each of the terms inside those parentheses. On the left, I haven't touched my 2x. 3 times 3 will be 9. 3 times negative 3x will be negative 9x equals negative 5. Now again, I have like terms that I can combine. Here, 2x and negative 9x both have an x in those terms, so they are like terms. I can combine them by saying if I had 2 of something and I subtracted 9 of that same thing, I would be left with negative 7 of x, whatever x is. So I'll combine these like terms to negative 7x. I haven't touched this positive 9 or this negative 5 yet. But now that I only have one variable over here, again, my goal is to isolate and solve for x. I need to move this term, this positive 9, to the right side. So it's being added to our variable. The opposite of addition is going to be subtraction. So I need to move it to the other side by subtracting 9 from both sides. I haven't touched my 7x. 9 minus 9 is 0, plus 7x is 7x, equals negative 5 minus 9 more, so 9 deeper into the negatives will be negative 14. Then finally, I'm very close to having x isolated, but there's a negative 7 in front of it. Now this isn't x minus 7, it's negative 7 as a coefficient times x. So to get that x by itself, because it has a coefficient which multiplies that variable, we need to do the opposite of multiplication. We need to divide each side by that negative 7. So I'll divide negative 7x by negative 7, and I have to divide the other side by negative 7. And I finally end up with x equals negative divided by a negative will be a positive. 14 divided by 7 is 2. So I believe the value of my x is 2. Let's write that up here. We believe we know x's value to be positive 2. I'm going to clean this up and move on to my third step, where I substitute the value of x into either of these equations. I've left this equation here. Remember, way back when we did our first step, isolating a variable, we isolated y. Well, now it's time to solve for y. And this equation is effectively the same as this first equation. I've just moved the terms around and simplified it so that I had y by itself. Well, conveniently, that's what we're trying to solve for. I can use this as one of my equations to substitute the value of x into. So I'm going to rewrite this equation, y equals 3 minus 3x. But I know the value of x is 2. So now I can simplify. Y equals 3 minus 3 times 2 is 6. 3 minus 6 is negative 3. So we believe y is negative 3. Now, again, I'm going to clean this up, and we're going to substitute the values of x and y into both of our original equations. Now, I am not going to use the simplified form of the first equation that we found in our first step, since if we made an error while changing this equation to this one, we might get a false positive. We might think that our equation is correct. However, it could have been an error we made in our first step. So I will not be using this form of the first equation. I'm going to use my original two equations to check my work. So I'm going to rewrite my first equation. 3y plus 9x equals 9. Substituting in the value of y to be negative 3. So instead of this y, I'll be writing negative 3, and the value of x to be 2. Let's confirm that this is a true statement. 3 times negative 3 is negative 9, plus 9 times 2 is 18 equals 9. 18 and negative 9 make positive 9, which is equal to 9. So we know that this is true for our first equation. Let's again substitute into our second equation and make sure that this one is true. So we had 2 times x plus 3 times y equals negative 5. We believe the value of x to be 2, so instead of that x we're going to write 2. We believe the value of y to be negative 3, so instead of y we're going to write negative 3, and let's again simplify this and ensure that this is correct. So 2 times 2 will simplify as 4. Positive 3 and negative 3 make negative 9. Is that equal to negative 5? When we subtract 9 from 4, we go 5 deep into the negatives, and that is equal to negative 5. So we know that our solution is correct. Next time, I'm going to be doing a hard version of systems of equations, substitution, where we have variables that appear on both sides of the equation. So we're going to have to simplify before we isolate. Hopefully this has helped you with medium difficulty systems of equations through substitution, where you do have to isolate your variable. Have a great day, everybody. Bye-bye!